Hello, everybody. Today we're going to continue our exploration of solving division problems using different models and strategies. And today we're going to shift back to using the area model that I just very briefly introduced to you a couple of weeks ago. It's going to make a little bit more sense this time. So a couple of pieces of note before we get going. If you are listening to this and you are thinking, hey, I've already heard this, you're right. This is the lesson for both Monday and Tuesday this week. It is the same. We are spending 2 days to make sure we understand how to use, draw, and make sense of an area model to solve division problems. So if it is Tuesday, you may need to listen to it again if you need a refresher or a reminder. Maybe you've got it, and if you feel confident, you can stop. You do not need to watch the video a second time if you understand how to solve the problems using an area model. So just recognize that. So today we are going to solve a few problems together, and I'm going to show you a couple of different ways of using the area model. First question, solve 48 divided by 4 using an area model. Draw a number bond and use the distributive property to find the quotient. So we've got lots going on here, guys. The first thing I want to draw your attention to is that we're using an area model. That's the biggest thing. When you see area model, I want you to immediately think rectangle. When we talk about finding area, we have been talking about areas of rectangles. So when you see that, you immediately need to start thinking in terms of rectangles. You are also being asked to draw a number bond and to use the distributive property to find our quotient. So we're going to include all of this, and it's going to all be based off of our area model. So we know we're going to solve 48 divided by 4. So I'm going to start by drawing a rectangle that represents my 48 divided by 4. My dividend goes in the middle. That's my whole total inside, 48 square units. And my length of one side is 4. What we're looking for is the length of our long side, right? We don't know that. So we're thinking 48 divided by 4. Right below it, I'm going to draw another rectangle that's the same size and shape, approximately, and I'm going to label this side 4. But instead of putting 48 in the middle, I'm going to start thinking of how I can break 48 up into some different parts that are much easier to divide by 4. So I'm immediately thinking, I know 40 is divisible by 4 really easily, so I'm going to break up my area model. And I'm going to say this part is going to be 40. That leaves the other part to be 8 because 40 and 8 makes my total of 48. Now what I really have is the problem of solving 40 divided by 4 and 8 divided by 4. And I'm going to show this in a number bond. If I draw a number bond and put my 48 up, what I've said in my second area model there is that I know 48 is made up of a 40 and an 8. So what I can do is I can say 40 divided by 4 to find this missing side. And I know that's going to be 10. So this length of this part of the rectangle is going to be 10. Now I can do my other littler rectangle. I can say 8 divided by 4. Remember, this is 4 here, this is 4 here, they're the same. So 8 divided by 4 will get me this missing part. And I know that's going to be 2. 8 divided by 4 is going to give me 2. So to find the whole side length here, all the way across, I'm just going to add 10 and 2 to get my 12. So we can see that the missing side length here is 12, and so therefore 48 divided by 4 is 12. Take a look at how we've used the distributive property. It's already right here. The distributive property is right here. We've done that. It looks just like our partial products, except for this time it's partial dividends. And I know that at least Mrs. Casano's class has already tried to explore this a little bit because Andrew used it in a question last week. And so now you guys can see it modeled for you a little bit more clearly, and you guys can give it a try for yourselves. Okay? Let's take a look at another one. 96 divided by 4 using an area model. All right, so once again, I'm going to write my division problem to start. We also need a number bond and the distributive property in some way. So I'm going to set up my number bond of 96. Now, I'm not going to draw all my parts coming out because I don't know how many parts I want. Remember, numbers can be broken up into several different parts. You don't have to stick with just two. I'm going to draw my rectangle for my area model. I know the whole total inside is going to be 96. My short side length is going to be 4. Now what I need to do is figure out how do I want to break up this big long guy to make this a little bit easier. Well, we just did something up here, didn't we? We know 40 is nice and easily divisible by 4, so I think I'm going to stick with that. I'm going to go with 40 here, and I know I can do another 40. That gets me to 80, and then I still have 16 left. So I'm going to split this one up into 3 parts, and that's okay. You can do that. So I'm going to split this up into 40 and 40 and 16. Okay, we'll do this one in red, and we'll do this one in green, and we'll do this one in blue. Okay, so now we're looking for this short length, we're looking for this short length, and we're looking for this short length. So we're going to start with our red. We've got the 40 divided by 4, and we know that's going to be 10. Now we've got our green part. That's also going to be 40 divided by 4. Oops. Sorry, trying to write small, guys. Is 10. And then I'm going to do my blue part. Whoops. Put my 10 here. Make sure we label our area model. And then I've got 16 divided by 4. And if I don't know that fact very well, I can go back to my skip counting. 4, 8, 12, 16. That was 4 times. So that's going to be 4. And I'm going to add all those up, 10, 24. So my total side length here, I think, is going to be 24. I've shown a number bond. I've used the distributive property in some way, that's right here. And I've used an area model, and I've shown my work on the area model. Just drawing this right here, guys, for your area model is not enough. Okay? You have to show me how you broke it apart. You cannot just write 96, 4, and 24 and say you're done. Because at this point, many of you are not there to ready to do that mentally. All you can do is show what you can do mentally. 40 divided by 10, that's a great mental math problem. 16 divided by 4, yep, that's a mental math. 96 divided by 4, not so much yet, okay? So you must show this way of breaking it down, okay? Let's take a look at a third problem, and I'm going to model it slightly differently. Before I get there, actually, if you did know 96 could be broken up into 80 and 16, if you recognize that you are comfortable doing 80 divided by 4, you are welcome to do that. Okay? And then 16 divided by 4, you are welcome to put those two parts together, and you can say this would be 20 plus 4 to equal 24. You will get the same answer. And then for your model, you would simply have drawn 20 and 16. Whoops. I labeled them wrong. Hold on. 80 and 16 with 20 and 4 as your side lengths to make the total of the 24. Okay? So you're going to think about what parts work best for you. Let's take a look at the last one, 72 divided by 3. Again, using an area model, so I'm immediately going to draw my rectangle. Whoops. 72. 3 is a side length. Looking for this guy right here. What is that long length going to be? I'm going to set up my number bond, 72. And this time, I'm going to think of it in a slightly different way. Rather than trying to break down the 72 into equal parts that I think might be divisible by 3, I'm going to think of my multiplication instead. So I'm going to ask myself 3 times what will get me really close to 72. So I know 3 times 20 is 60. That's pretty close. What if I added another 10 and I tried to do 3 times 30? Well, that's 90, so that's too far. So I'm going to go with that. I'm going to try 3 times 20, and that's going to give me 60. So I'm going to show that with a smaller rectangle. I'm going to show 3 times the 20 equals my 60. Now how much is left to make 72? And really, this should be a little bit longer. Now I know there's 12 more left to get to 72. So I can ask myself 3 times what is going to be 12 to get me that other part, that other rectangle. And again, if you don't know that fact, you can skip count, but hopefully you guys know this by now. 3 times 4. So in this case, where is our answer? It's not over here. That's just checking to make sure we got to our dividend. But our answer in this case is right here in the middle, just like when we count up in subtraction. It's going to be 20 plus 4 to equal 24. And to show my bond, I would then show that I made a 60 first, and then I made the 12. If I want to look back at my question, did I use an area model? Yep, that's right here. Did I use a number bond? Yep, that's right here. Did I use the distributive property? Yes, that's right here. This time my distributive property was with partial products. In the previous questions, I used it with partial quotients. It doesn't matter whether you use partial products or partial quotients. It is using the distributive property, and that's what they're asking. So you can decide, is it easier for me to think of the missing factor and try to do multiplication to get up to my dividend? Or do I want to break it into parts and think of smaller division facts? Now it's your turn to go ahead and give it a try. Remember, you're going to do this Monday and Tuesday. We're going to get a lot of practice of this in. Let me know if you need any help, and